Hello everyone, welcome to our class. My name is Ko-Chen Lee. In today's sections, we will talk about the computer architectures. The objective for this section is listed as follows. In these sections, first, we will learn why we need to understand how computers work, and learn what a CPU is, the most important part of the computer, and what it's made of. We also will learn the importance of the von Neumann architecture. To know how the computer works, we need to understand how a computer uses memory and learn what a system bus is and what its purpose is. Also, we need to understand the difference between memory and storage and be able to describe basic input-output devices. Finally, we will discuss how a computer uses interrupts and pollings. After today's sections, we should be able to have a full view of the computer architectures and use that in the future to choose the best computer hardware for you. Before we start, let's look at some basic ideas about computers. First, the computer hardware is designed to run software. All the hardware are designed to fit the software requirements or functionalities, such as input and output devices. Second, the purpose of the computer is to accomplish desired tasks. Not only the computational tasks, various tasks can be performed on the computers. Third, professionals need to understand logic connections between hardware and software. To design the software solving the new task, the professionals need to understand what resources and functionalities a computer can provide. All in all, the term computer architecture is the organization of hardware components into a computer system. It's very important to understand the computer architecture for people who want to use computer to solve problems. So, how do computers work? Basically, it's a machine that takes user's input as an instructions, then executes and output the corresponding result. Say you need a computer to compute 1 plus 2 for you. In this case, 1 plus 2 would be the input. The computer takes the input and compute the result, then output 1 plus 2 equals 3 for you. To be simply said, the computer architecture contains 3 main parts: input unit, processing unit, and output unit. However, the real-world model is usually expressed as for the von Neumann machines. To understand the computer architectures, we have to look at the von Neumann machines, which is a conceptual model of a computer architecture. By treating the instructions in the same way as the data, the machine could easily change the instructions. In other words, the machine was reprogrammable. Computers with von Neumann architecture are known as stored programs. This means that the computer does not need external switches to run. All the instructions and data are stored in the random access memory, as known as RAM. From the slide, we can see there are 4 main components in the one Newman machine, which are input devices, output devices, CPU, and memory. They are able to communicate to each other using bus. We will use this architecture as the guideline to look at computer hardware for the later parts in these sections. The one Newman machine is defined as a multi-purpose machine with the following characteristics. First, binary instructions are processed sequentially by fetching an instructions and then executing. The software program is the sequence of binary instructions, and the computer runs the program. This makes the computer to be programmable by rewriting the program. Second, instructions and data are stored in main memory system. This makes the computer to be able to run the program repeatedly. Third, instruction execution is carried out by CPU. All the programs need to be brought to the memory and compute in the CPU. Even today's computers is still running under this mechanism. Fourth, CPU has the capability to accept input from and provide output to external devices. The main components for a computer can be grouped into several categories. The computing unit, which usually refer to the CPUs. However, the computation requirements for the computer graphic is getting heavy. Some graphic cards have their own computing units called GPU. But still, in this category, we will only talk about CPU, since the CPU is still the main computing units in the computer. The second category is the storage devices in the computer. Storage in the computer is used to store data and program. 2 main types of storage devices in the computer. One is memory. Another one is permanent storage devices. The main difference between these two is that all the data in the memory will be lost when the power is off, but not for the permanent storage device. We will discuss more in details when we talk about this tech category. The most familiar category for the computer users is the input devices. All the devices we use to input data to the computer are listed in the categories such as keyboard, mouse, touchpad, etc. Also, the other familiar category is the output devices, which the computer uses to communicate to outside world, such as monitor and speakers. The last category is the peripheral devices. In this category, devices use buses such as USB and SCSI to extend the functionalities of computer. Once information has been sent to a computer by one of the input devices, it's processed. The computer uses its brain to process the information. The computer's brain is called the CPU, or Central Processing Unit. It does all the computations in the computer. All the instructions are stored in the memory. CPU takes the input from the memory and computes in the CPU. Finally, output result to the memory. Computer CPUs are composed of thin layers of thousands of transistors. Transistors work as thousands of electronic switches, carried out ones and zeros binary values. Several design circuits perform specific functions. 4 basic functions are designed in the CPU. They are adder, decoder, shifter, and storers. Modern CPUs are called integrated chips. The idea behind an integrated chip is that several types of components are integrated into a single piece of silicon, a single CPU, such as one or more execution cores, arithmetic logic units, or floating-point processors, registers, instruction memory, cache memories, and the input-output controllers, which we call bus controllers. The ALU is the part of a CPU that performs all the arithmetic computations, including additions, subtractions, multiplications, and divisions. The arithmetic logic unit also performs all logic operations. The ALU is literally the fundamental building blocks of the CPU. And even the simplest processors contains an ALU. The control unit communicates with both the arithmetic logic unit and memories, and literally directs the entire computer system to carry out or execute stored programs instructions. Registers are the temporary storage areas for instructions or data within the processors. Registers are basically special storage locations somewhat similar to a computer's memory, though contained with the processors and exceptional faster. Computer data storage is often classified into primary memory and secondary memory. Refers to computer components and recording media that retain digital data. Data storage is a core function and fundamental components of computers. Primary memory usually refers to semiconductor storage, read-write random access memory, typically DRAM, dynamic RAM. Primary memory can refer to other forms of fast but temporary storage. Secondary memory, mass storage, refers to stored devices and their media not directly accessible by CPU, such as hard disk drives, CD, DVD drives. 2 basic types of memory, ROM and RAM. ROM, read-only memory, is the type of memory used in the computer. Data stored in ROM cannot be modified, so it's mainly used to distribute firmwares and BIOS, as known as basic input-output systems. RAM, random access memory, a type of computer memory that can be accessed randomly. That is, any data in memory can be accessed without touching the preceding bytes. RAM is the most common type of memory found in computers and other devices. Data stored in the memory is temporary. Since RAM uses electricity to retain data, all the data will be lost while the power is off. Random access memory, we usually call RAM, is temporary memory. The computer holds information in this memory and gets it when it needs it. If a computer has more RAM, it can solve problems and process information faster. If you are upgrading your computer, more RAM is a great thing to add. Two main characters we have to know about the memory. First, data or program has to load to the memory first before execution. Second, data will be lost when the power is turned off. To store the data permanently, we have to use so-called secondary storage devices to store our data. There are two types of random access memory, DRAM and SRAM. DRAM, dynamic random access memory. The structure of DRAM is simple. It uses only one transistor and one capacitor to store a bit, compared to 6 transistors in SRAM. This allows DRAM to reach very high density. Also, it consumes less power and is even cheaper than SRAM. But its disadvantage is that since it stores bit information as charge, it needs to be consistently refreshed to maintain data. This is known as refreshing the memories, and it requires extra circuits adding to the cost of the systems. SRAM, static random accessible memory. SRAM is made of flip-flop circuits to store each bit. Each bit is stored as a voltage. Each memory cell requires 6 transistors, thus giving chip low density but high speed. However, SRAM is still volatile in the sense that data is lost when powered down. Disadvantages are more expensive and also consumes more power than DRAM. In high-speed processors, SRAM is known as cache memory and is included on the processor chip. However, high-speed cache memory is also included external to the processors to improve total performance. Mass storage refers to the storage of large amounts of data in the persistent and machine-readable factions. It has greater storage capacity than memory. Devices and systems that have been described as mass storage include hard disk drives, optical disk drives, flash drives, etc. Mass storage includes devices with removable and non-removable media. It is cheaper than memory per megabyte. It does not include random access memory, which is volatile in that it loses its contents after power loss. So the data will be retained even the power is turned off for the mass storage. Hard disk drives are the most common mass storage devices. It uses magnetic metal platters to store information. It consists of one or platters coated with magnetic particles and with magnetic rewrite heads arranged to write data to the surfaces and read it from them. The hard drive disk is formatted by the rewrite heads recording data on disk surface in the concentric circles. They are defined as tracks. Data are arranged in tracks. Each track can be divided into sectors, which is the smallest data unit for the hard drive. These show the platters and rewrite head inside the hard drive. While the platter spins, the rewrite head moves forwards and backward to access the data. The platter typically spins at speeds of 7,200 or more RPM, revolutions per minute. When we format a disk, that means we check the available space, assign the address for each track and sector, and get ready for writing the data. When it comes to decide the type of mass storage, one factor to be considered is the cost of per megabyte. If you compare the cost to RAM, you will figure out that cost of mass storage is way cheaper than memory. But in the other hand, the other important factors, access speed. The speed of mass storage is way slower than memory. Take the hard drive for example. The hard drive takes around 10 milliseconds comparing to 8 nanoseconds the speed of RAM. All in all, the mass storage is cheaper, non-volatile, but slower. The memory is faster, but more expensive and volatile. The other common mass storage is the optical storage. Without using the magnetic tracks, optical storage uses laser technology to access data. CDs, compact discs, and DVD, digital video discs, have become popular forms of mass storage devices. Several reasons for that. First, CDs and DVDs are even cheaper than hard disks. And the second important reason, they are portable. It's the easy way to carry your mass data around through these kind of storage devices. The technique of writing data to optical storage is to use a laser to burn tiny pits on the surface of the disk. These pits are then representing ones and zeros when laser head read the data reflecting from the smooth surface or a pit. Recently, USB drives, sometimes we call flash drives or thumb drives, are getting popular as the choice of portable storage. The space of the flash drive nowadays is even larger than DVD, and the access speed is much better than optical storage. Through the USB port, the flash drive can act in plug-and-play fashions and support hot swap. Hot swap means replacing the device without shutting down the systems. Moreover, the flash drive takes very small space, even can fit it into a keychain. While plugging into the computer, the operating system will show it as a removable hard drive. But it really uses IC chip made of flash memory. The flash memory is volatile, meaning the data will be retained while the power is off. For the input devices, we say all the devices that allow user to input data to a computer can be called as input devices. They convert data from a human understandable format to a format that the CPU understands. The common input devices include the keyboard, mouse, joystick, and scanner. The keyboard, the most popular input device. It is used to translate the keystroke to binary signals. As to the mouse and joystick, they are used to convert the movement and location data and send to the computers. Keyboard is the main input device for most computer systems. The keyboard connects to CPU through controller circuits and system bus. For each keystroke input, the signals will be interpreted as computer-readable signals and send it through system bus. Once the CPU receives the signals, then the input will be expressed as letters, numbers, or control code. Keyboard and most other I/O devices connect to the computer through an I/O port. Ports are connectors on the outside of the computers that allows I/O devices can be plugged in. But we can find most I/O devices with alternate interfaces like USB today. Since the USB the most common interface for peripheral devices. Without the output devices, computer cannot communicate to the outside world. It is necessary for the computer to have various output devices to send or express the results of the assigned tasks. Monitor is the primary output device for the most computer systems. For years, monitors are the CRT devices. In an RGB CRT, three electrical streams representing red, green, and blue are used to code the color information. Nowadays, LCD become the most popular monitors because it is lighter, thinner, and low power consumption. To choose a suitable monitor, two factors can be evaluated. First, the resolutions. That means the number of dots or pixels on the monitor. Second, the refresh rate. The number of times an image can renew on screen. Both factors are the higher the better. And of course, the better the more expensive. The printer is another common output device. Two major types of printers, inkjet and laser printers. The inkjet printers moves the print head to spray the tiny droplets of ink onto the paper. The laser printers uses electronic drums and toners to print the data. Typically, the laser printer prints faster and cheaper than inkjet printers. And the quality of a printer can be measured by the resolution, which is dots per inch, and the speed, which is pages per minute. Another common output device is the sound card. Although some motherboard has it integrated in the chipset, through the PCI interface, sound card mainly works for digitized sounds to be used or stored in the computer. In the other hand, convert the digital sounds back to analog format. Last but not least, the system bus is a set of wires or rules facilitating data transfer. All the components are connected via system bus. The von Neumann machine uses system bus to get information from input devices, read instructions from the memory to processors, and sending the results to the output devices. The signals running on the bus can be divided into 3 separate signal groups: the control signals, address signals, and data signals. Those signals follow the set of rules which are called bus protocols. The modern bus standard is the PCI bus. Peripheral components interconnect. As with all other buses, the PCI buses is a set of wires combining with bus protocol that allows computer components to be able to communicate with each other. In addition to the system bus, computer systems allows secondary buses for I/O device to connect to the systems. Here we introduce one of the popular buses called SCSI, Small Computer System Interface. SCSI connects different types of I/O devices to the computers. Other than the reliability and high performance, SCSI provides bus mastering that has permissions setting control by the system. Another popular peripheral bus is Serial ATA, which is improved by the old parallel ATA. Based on the von Neumann machine, CPU executes instructions along with the clock. Other than that, the computer uses interrupts and polling to talk to I/O devices. Polling is a technique for CPU to see whether I/O devices require attention. On the other side, interrupt allows I/O devices to talk to CPU while CPU is busy. So after today's sections, we should have a basic idea of choosing the best computer hardware for us. No one size fits all. It depends on what you need to solve your problems. But still, some common factors are used to evaluate a computer system, such as machine objectives, clock speed, memory type, bus speed, and the hard drive speed. This is all for today's sections. Thank you for your listening.